Okay, let's unpack this. Imagine you've asked an AI to write an entire document, maybe answer a complex question, or just, chat. How do you really know if it's not making stuff up? Is it actually helpful, or is it just kind of rambling? And is it always respectful to you? These aren't just minor things, are they? I mean, think about the stakes. An LLM summarizing critical documents could, well, completely fabricate disastrous information, or one helping doctors make treatment decisions. If it hallucinates, that could seriously impact someone's life, even in everyday business like customer service or maybe content creation. Accuracy is just absolutely crucial for, well, business continuity.
It's true. And what's fascinating here is the challenge, it just grows exponentially when you think about scale. Having humans review thousands, maybe tens of thousands of customer conversations every single day, it quickly becomes, well, impossible. So as more and more companies deploy these powerful LLMs, the need for robust automated evaluation has become incredibly urgent.
Yeah, and that's the thing, isn't it? Your traditional metrics or even human reviewers, they often fall short. They struggle to capture the really nuanced aspects of what these LLMs are putting out. And this has led to a really innovative and honestly surprisingly powerful solution, using LLMs themselves as judges. So today we're doing a deep dive into this practical framework for LLM as a judge evaluation. We're pulling insights from a top ebook on this, Mastering LLM as a Judge. Our mission really is to help you understand how these larger language models can assess outputs from other LLMs. We'll explore approaches that try to balance accuracy, cost, and speed. And ultimately, we want to guide you in building reliable evaluation systems. Systems that can catch issues before they ever reach a user. So what is LLM as a judge exactly? Our source describes it as a powerful approach that's really changing how we evaluate AI systems. Think of it like this. Imagine a chef judging a cooking competition. You wouldn't just measure ingredient temperatures, right? You taste for flavor, creativity, presentation. Similarly, some crucial AI aspects just can't be boiled down to simple numbers.
Exactly. And if we connect this to the bigger picture, LLM as a judge
Yeah.
uses a powerful LLM, think GPT-4 or something similar, to assess the quality of all sorts of inputs and outputs. This could be from other AI models or even from human annotations. Its versatility really comes from how well you craft the prompts you give it.
Okay, so take a customer service AI, your standard statistical metrics like average response time. They won't tell you if the response is actually, empathetic. But an LLM judge could evaluate things like, does it address the customer's real underlying concern? Is the tone professional but still friendly? Does it handle cultural nuances correctly? And maybe most importantly, would this interaction likely lead to customer satisfaction? That's a level of qualitative analysis we've struggled to scale before.
Right. Or think about retrieval augmented generation RAG evaluation.
Yeah.
You could ask an LLM judge to figure out if the information chunks retrieved are truly relevant to the question asked. Or critically, if the final answer is actually grounded in the context provided and free of any fabricated information, any hallucinations. It's about moving beyond simple keyword matching to actual comprehension.
Okay, that makes sense. Now, for a long time, human judges have been seen as the gold standard for evaluating AI, right? But it's an interesting paradox, actually. There's this paper provocatively titled, Human Feedback is Not Gold Standard. And it really highlights some key shortcomings with relying solely on humans.
It's fascinating, isn't it? How much these confounding factors can impact human judgment. For instance, the paper points out that evaluators are often swayed by how confidently information is presented. So outputs that sound more assertive are often perceived as more factually accurate, regardless of whether they actually are.
Wow. Which means human preference scores can be pretty subjective, and that introduces all sorts of unintended biases. And one really concerning finding they mention is that models can get favorable ratings even when they're factually wrong just because the style of the output is preferred. That disconnect is a significant risk, especially when you're trying to build trustworthy AI.
Absolutely. And this can create a really harmful feedback loop. If you're training your models mainly on this potentially biased human feedback, you might inadvertently just be increasing their assertiveness, which leads to AI systems that seem overconfident, potentially mislead users, and over time erode trust. So as a user yourself, you should definitely be aware of this and maybe carefully evaluate how your AI feedback mechanisms are calibrated.
Yeah, good point. Not to mention just the practicalities. At enterprise scale, human evaluations are just incredibly expensive and super time consuming. You need meticulous coordination, maybe custom interfaces, really detailed instructions, tons of data analysis. It's a huge bottleneck.
hmm So given all those challenges with human evaluation, it's pretty clear why LLM as a judge has emerged as such a powerful alternative. The advantages are quite stark when you line them up.
Absolutely. I mean, first, just think about scalability. LLMs can process vast amounts of data incredibly quickly. That makes them ideal for large-scale, continuous evaluations where humans just, well, can't keep up. And that leads directly to significant cost effectiveness, right? By reducing the need for all that extensive human labor.
Exactly. And beyond just speed and cost, they offer incredible flexibility. You can fine-tune LLMs or use clever prompt engineering for highly specific tasks. This enhances their relevance and allows for systematic refinement to reduce certain biases that human evaluators might accidentally introduce without even realizing it. Plus, their inherent language understanding means they could evaluate really intricate texts across all sorts of formats, providing truly nuanced assessments that go beyond surface-level checks.
Okay, so let's say you're sold on the idea. An LLM judge sounds promising. The practical question then becomes, how do these AI judges actually give scores? How does it work in practice? Well, our source outlines three primary methods. First up is single output scoring, but without a reference. So here, the LLM assigns scores based only on some predefined criteria and the output itself. The scores are usually on a discrete, clearly defined scale, like 1 to 3 or 1 to 5. For example, maybe you're evaluating a customer service response like, our team is working on your order, and you'll receive a tracking number within 24 hours. Against, say, a 1-3 scale. 1 is unprofessional, 2 is professional but incomplete, 3 is professional, empathetic, and clear. An LLM might score that response at 2.
Right, and that too isn't just random. It means, okay, it's professional, sure, but maybe it doesn't fully address potential deeper issues like why there's a delay or if compensation is maybe warranted. So the LLM isn't just looking for polite words, it's digging into whether the core customer need, including potential follow-ups, has been fully addressed.
Exactly. Then the second method is single output scoring, but with a reference. This approach includes supplementary information, like a piece of context or a golden answer, to help the LLM judge. This usually leads to more nuanced evaluations, especially for complex outputs. For instance, imagine evaluating an AI output like, the new environmental law requires companies to reduce carbon emissions by 30% by 2030. But if your reference text, the ground truth, specifies for companies with over 500 employees, the LLM would score it, say, a 3 fee on a scale meaning accurate but incomplete because it missed that critical detail about company size.
Hmm.
This approach makes sure the LLM judge isn't just judging in a vacuum, right? It's given the necessary context to make a fully informed decision. It helps catch those subtle but important omissions that might otherwise slip through. Makes sense. And the third method, that's pairwise comparison. Here, the judge LLM is shown two different outputs, side by side, and asked to pick which one is better based on specific criteria you give it. This is particularly good for getting around some of the challenges with assigning absolute scores. For example, comparing two product descriptions. One is maybe general and a bit bland, the other is more specific, engaging, has better details. The LLM judges the second one as superior.
Yeah, this method can be really effective because, honestly, it's often easier, even for an LLM, to pick a winner between two options than to assign a precise score on an absolute scale. It focuses on relative quality, which can sometimes be more robust and consistent. This does raise an important question, though. As you think about your own systems, you'll really need to choose the method that best fits your specific use case. You've got to consider things like how much data you need to process, your scalability needs, and maybe how you'll manage consistency, especially as the LLM judges themselves get updated over time.
Good point. So if you're listening and thinking, okay, maybe I should try this, you might be asking, when should I use LLM as a judge? Well, first, think about the nature of your task. Is the output subjective? Things like style, tone, creativity? Does it require understanding complex context? Do your traditional metrics just, well, miss those important qualitative aspects? If yes, then LLM as a judge really shines here. Next up, consider your scale requirements. Do you need to evaluate thousands, maybe millions of responses quickly? Is manual human evaluation just completely impractical? Do you need really consistent criteria applied across a massive number of samples? As your scale increases, LLM as a judge becomes exponentially more valuable.
And, of course, you need to do a cost-benefit analysis. Is the cost of those LLM API calls actually justified compared to paying for human evaluation? Do you need really rapid iteration in your development cycle? Can you maybe leverage smaller, more efficient models for just an initial screening first? Also, think about the complexity of your evaluation criteria. Do you need simultaneous evaluation of multiple aspects, maybe coherence, relevance, and accuracy all at once? Does it require cross-referencing context or balancing competing factors? The more complex the criteria, the more an LLM judge can potentially help.
Okay, so the best use cases seem pretty broad then. Content generation, quality checks, evaluating conversational AI responses, checking document summarization accuracy, ensuring style and tone consistency, context-aware fact-checking, even measuring something as fuzzy as creativity. It's surprisingly versatile.
But, if we connect this back to the bigger picture, when should you maybe consider alternatives? Well, if you already have solid ground truth and objective hard metrics are good enough, maybe stick with those. Or if you just need simple binary correct and incorrect judgments. Definitely if extremely high stakes decisions are involved, things with major legal or financial implications. Or when specific legal or compliance verification is absolutely required, you'll likely need human oversight. Often, though, what really works best is a hybrid approach. Maybe use LLM as a judge for that initial large-scale screening, and then follow up with targeted human review for the critical or tricky cases. Or combine LLM judgments with traditional metrics for a really comprehensive evaluation. It's not always an either-or situation.
Right, that makes a lot of sense. Use the right tool for the right job or combine them. But, for all the power of LM as a judge, it's not perfect, is it? We touched on this earlier. These LLM-based evaluations can have their own biases, often mirroring human biases because, well, they're trained on human annotated data. The good news, though, is that these can often be systematically identified and hopefully addressed.
That's a really crucial point. Our source highlights several key issues to watch out for. For example, there's something called nepotism bias. It sounds funny, but basically an LLM tends to favor text generated by itself or models similar to it. So GPT-4 evaluating an output might rate its own response about, say, exercise benefits higher than an equally informative answer generated by Claude, just because it recognizes its own style.
Huh, that's fascinating. It's like it prefers its own voice or way of writing.
Kind of, yeah. Then you have verbosity bias. LLMs often, sort of, equate quantity of information with quality. They tend to favor longer, more verbose text, even if it's redundant, over concise content. A lengthy, rambling restaurant review might actually get higher ratings than a perfectly concise, to-the-point one.
So more words equals better, in the AI's view, sometimes.
Sometimes, yes. And related to that is authority bias. LLMs can assign greater credibility to statements just because they sound like they come from a perceived authority, regardless of the content's actual accuracy. An LLM might favor a renowned physicist's explanation of global warming over a more accurate explanation from, say, a graduate student, purely based on the perceived source authority.
Wow. So it's not just about what's said, but who it sounds like is saying it. That's tricky.
It is. We also see positional bias. This means LLMs might give undue importance to information based on where it appears in the text, like at the beginning or the end. Or they might systematically bias scores based just on the presentation order. You could show the same two AI responses to an LLM evaluator, but just swap the order you present them in, and you might get different scores.
Seriously, just based on which one it saw first.
It can happen, yeah. Then there's beauty bias. LLMs might prioritize text that's, well, aesthetically pleasing, maybe well-structured, uses nice vocabulary over text that is factually accurate or complete, but maybe a bit plain. A poetic but factually incomplete smartphone description might get preferred over a dry but comprehensive spec list.
That's almost unsettling, isn't it? That aesthetic appeal could actually outweigh hard facts in an evaluation.
It's a real challenge we need to be aware of. And for lengthy text, LLMs can exhibit attention bias. They often show a kind of U-shaped attention pattern. They give more weight to info at the beginning and the end, what we call primacy and recency bias, and might miss crucial details buried in the middle. So a response with a strong introduction and conclusion might get a high score even if the core content in the middle is shallow, while a response with critical technical details right in the middle might get undervalued.
Okay, so the middle gets lost sometimes.
It can, yeah. And one more. Fallacy oversight bias. LLMs might fail to identify logical fallacies in reasoning and could even inadvertently perpetuate them. For example, if a user writes, "This investment strategy must be reliable because all the successful traders are using it." That's a classic appeal to popularity fallacy. The LLM might just accept the premise and reinforce that faulty reasoning in its evaluation or response.
Wow, it's almost like these AIs are picking up our own human cognitive quirks and then amplifying them in some cases. So if the judges themselves have these kinds of blind spots, how do companies out there on the front lines actually begin to build trust in these systems? How are organizations tackling these LM judge biases in the real world?
Well, that's the million-dollar question, isn't it? Companies like LinkedIn, for instance, have put a lot of effort into this. They've developed really comprehensive evaluation frameworks. Their focus has been particularly on domain-specific challenges, like evaluating interactions related to job assessments, to establish incredibly consistent criteria. They actually built infrastructure to evaluate something like 500 conversations daily, tracking metrics across quality, hallucination rate, coherence, stylistic elements, the works. To speed things up, they developed model-based evaluators to automate parts of the assessment, allowing for much faster experimentation. What they learned, though, was that getting past about an 80% quality benchmark required really sophisticated error analysis and targeted model refinement. It really highlights that while significant progress has been made, a truly comprehensive solution, one that perfectly combines rigorous methodology with practical scalability, well, it's still very much a work in progress.
Right, so it's definitely a journey, not a final destination for many organizations working on this.
Exactly. Another really interesting and practical approach comes from a company called Galileo. They have a method called chain pull for LMN as a judge. They operate on an evaluation first principle, which is smart. What they do is combine chain of thought prompting, or CoET, with a kind of polling mechanism for a more robust assessment. Chain of thought basically encourages the LLM to articulate its reasoning process step by step before it gives the final answer. It's like asking a student to show their work on a math problem.
Ah, okay, so you get to see the thought process behind the judgment, not just the final score. That makes a lot of sense for transparency.
It really does. And it makes the judgment more trustworthy. Chain pull also leverages response diversity. They get the LLM judge to generate multiple independent evaluations for the same output, and then they aggregate them. The idea is that valid arguments or correct assessments tend to converge, while invalid ones or random errors tend to scatter. This allows Chainpool to produce a more nuanced score that also reflects the LLM's level of certainty or agreement with itself. Plus, they emphasize using meticulously fine-tuned prompt engineering. This helps minimize those inherent biases we talked about, and they also use clever techniques like batch processing to cut down on costs. It's a very thoughtful, multi-layered approach.
That sounds really sophisticated. So if you're listening and planning on using LLM as a judge, being super mindful of these potential biases is clearly critical. As you think about applying these kinds of bias mitigation strategies, you'll need to consider first your bias assessment. Which biases are most likely to affect your specific task? Are you evaluating multiple different LLMs, which might trigger nepotism bias? Or are your criteria maybe implicitly favoring longer answers, leading to verbosity bias?
Right. Then you need to think about your mitigation strategy. Can you implement multi-model evaluation, maybe averaging scores from different judges to reduce nepotism? Could you standardize input lengths somehow to combat verbosity bias? Or maybe anonymize the source of the text to prevent authority bias? Some people even suggest a kind of rotation system where different LLMs evaluate each other.
Like peer review for AIs.
Exactly. And finally, you have to consider the implementation complexity. Can you realistically implement something like chain of thought reasoning? Do you have the infrastructure to manage multiple evaluation passes and aggregate the results? These more advanced bias mitigation techniques are particularly powerful for things like comparative analysis of different model outputs, for quality assessment that requires really nuanced understanding, for tasks where getting multiple perspectives enhances accuracy, and definitely in scenarios where you need transparent reasoning chains for auditability or debugging.
Okay, this is all great, but we keep mentioning cost and scale. If these massive general-purpose LLMs like GPT-4 are potentially too expensive or slow for constant real-time evaluation on everything, what's the solution for scaling this up efficiently? Like imagine that customer service chatbot handling thousands of queries every hour. You need to evaluate those responses quickly. Using the biggest models for every single one sounds pricey.
That's exactly where the industry is seeing a really significant breakthrough. The development of specialized, smaller language models, or SLMs, which are specifically designed and optimized just for evaluation tasks. Unlike their bigger general-purpose cousins, these SLMs are built to excel at specific tasks, like judging quality or detecting issues, but with much less computational overhead.
Smaller models for judging, what makes them such a potential game changer?
Well, their advantages are pretty compelling. First, enhanced focus. Their entire capacity is dedicated to evaluation, not trying to do everything else. Second, deployment flexibility. Often, these smaller models can run locally or on private infrastructure, which helps address data privacy concerns. Third, they're generally production-ready, much faster, offering lower latency, which is crucial for rapid, even real-time evaluation. And critically, they offer significant cost efficiency. We're talking potentially orders of magnitude lower operational costs compared to using the largest LLMs for the same evaluation tasks.
Wow, orders of magnitude cheaper. That's a massive shift.
It really is. Architecturally, they often have things like a multi-headed design, where different heads are tailored with specific evaluation criteria. They use optimized processing for handling inputs efficiently, and they have an adaptable structure that makes them highly fine-tunable for specific domains or quality standards. The truth is, the need for these SLMs arose because, let's face it, using the big flagship LLMs for continuous evaluation in production is just too costly for many use cases. Plus, relying on external APIs constantly raises privacy flags for businesses, and robust corporate AI governance really demands dedicated internal frameworks for monitoring.
That makes perfect sense. So can you give us an example of this kind of specialized evaluation model in action?
Yeah, a really prominent example right now is Luna 2. This is the latest generation of Galileo's Luna SLMs, and they are purpose-built specifically for scaling AI evaluations efficiently. It really embodies that promise of real-time guardrails without the big-time bill. The benefits are pretty profound. The claim is it's an order of magnitude cheaper and faster than most large LLMs, which is what truly enables things like real-time guardrails to catch risky AI actions before they actually execute. It's already fine-tuned specifically for evaluation tasks, so it provides comparable performance to top LLMs right out of the box for many common criteria. And importantly, it can be further fine-tuned with your specific data for even better accuracy on your unique tasks.
Okay, hold on. Comparable accuracy to top LLMs like GPT-4, but way cheaper and faster. That sounds almost too good to be true. How does that work?
Well, technically, the Luna models, they come in 3 billion and 8 billion parameter variants, which is much smaller than the huge models, are actually fine-tuned versions of capable open-source models like Llama. They're optimized specifically for low latency and cost-effective evaluations, often running on specialized inference engines. They output very precise confidence scores, or log probabilities, for their metric judgments, which makes their evaluations highly reliable and transparent. They also use things like lightweight adapters, so you can add custom metrics easily without retraining the whole model. According to their published benchmarks, Luna 2 can cost something like 0.02 per million tokens processed, with latency around 150 milliseconds, while maintaining accuracy scores correlations with human judgment often above zero point 0.9. This significantly outperforms models like GPT-4o, its mini version, and even specialized safety tools like Azure Content Safety in terms of cost and latency, while keeping accuracy very high.
That's really impressive performance per dollar.
It is. And in action, these Luna models can power custom LLM metrics for pretty much any production use case. A key application is enabling guardrails for those complex, multi-step agentic workflows, allowing systems to catch potentially risky actions before an AI agent actually calls a tool or takes an action in the real world. It really changes the economics and feasibility of continuous AI evaluation and safety monitoring.
Okay, so after hearing all of this, the different methods, the biases, the potential of SLMs, you're probably thinking, right, this sounds important. How do I actually build an effective LLM as a judge system myself from the ground up?
It feels a bit like setting up a highly specialized internal audit team, doesn't it? You need to carefully define what they're looking for, exactly how they should report their findings, and crucially, how you'll check their work to ensure they're reliable. That's a really good analogy. And yes, the process can be broken down into some key components. Our source suggests about 5 steps. First, you really need to determine the evaluation approach. And this is more than just picking ranking versus scoring. You need to design a multidimensional system that truly aligns with your specific business needs. For customer service, like we discussed, you might need to evaluate problem resolution, tone, actionability, and maybe compliance all at once. Crafting an effective system really starts here, deciding on ranking versus absolute scoring, what scales to use, and what kind of supplementary information like context or reference answers might help your judge make better decisions.
Okay, so step one is really setting the foundation, defining what kind of judgment you actually need from the AI judge.
Precisely. Second, you have to establish clear, unambiguous evaluation criteria. What exactly are you judging? Will you focus purely on factual accuracy, or is stylistic quality also important? How critical are things like clarity, sticking to the provided context, outputting in a specific format like JSON, or avoiding certain restricted keywords? Does the output need to answer all parts of the user's question? These criteria become the LLM judge's detailed rubric. Third, you must define the response format. How should the judge LLM actually report its rating? It's generally best to use discrete scales with a limited number of values like Boolean, true, false, or categorical, e.g. excellent, good, poor, as these tend to be more reliable and easier to interpret than, say, a continuous 0-100 score. And you should specify a really clear output format, maybe JSON, that includes not just the final score or value, but also an explanation or reasoning for the judgment.
Ah, that helps make the AI's thought process transparent, like with chain of thought.
Yes, exactly. It's crucial for debugging and building trust. Fourth step, choosing the right LLM to be your judge. This is a balancing act. You need to weigh performance versus cost generally. Stronger LLMs make better judges, but cost more per evaluation. You also need to consider task specificity. Does the judge model need specialized knowledge? API availability and reliability are key practical concerns. You might also want to consider its fine-tuning potential if you need custom capabilities. And critically, you'll need to adapt your prompts and criteria specifically for the chosen LLM's strengths and weaknesses.
Okay, that makes sense. Choose your bread wisely. And finally, what are the broader considerations beyond these core steps?
Well, there are several other important considerations. You need to regularly check for and mitigate those biases we discussed earlier. You have to ensure the judge remains consistent over time, especially if the underlying model gets updated. Thoroughly testing with edge cases is vital. You should strive for interpretability, understanding why the judge made a particular decision, and of course you need to ensure the whole system is scalable, so it can grow with your needs without breaking the bank or slowing things down.
Right, so you've built it following these steps, but then how do you validate this LLM judge? How do you make sure it's actually reliable and effective? It really is like auditing your auditor, isn't it?
It absolutely is, and there's a systematic, almost scientific process for this validation. Again, about 5 steps here. First, you need to select your test data carefully. You need a representative sample data set that includes objective tasks, like math problems where there's one right answer, subjective tasks, like judging writing style or creativity, and maybe mixed data that combines both elements.
So you need a comprehensive test suite that covers all the kinds of things your judge will see in the real world.
Exactly. Second, you need to generate test outputs for that data. And these outputs should cover the entire quality spectrum, from clearly excellent responses down to obviously poor ones. You should also include challenging edge cases, outputs with varying levels of complexity and different stylistic approaches. This ensures your judge is tested across the full range of possibilities it might encounter. Third, you have to choose your validation metrics. How will you measure the judge's performance? For those objective tasks, you can often use straightforward statistical accuracy scores. But for subjective evaluations, you usually need human annotations as your ground truth to compare against. For mixed data, you'll likely use a combination of metrics. Some key metrics people use are precision, which tells you how often the judge is correct when it identifies something as good or meeting a standard, and recall, which measures how many of the actually good responses the judge successfully identifies. You want both to be high. Then there's AUROC, or area under the ROC curve.
It's a bit more technical, but it basically evaluates how well the judge balances between being too strict, missing good responses, and too lenient, accepting bad ones. And for subjective tasks, Cohen's kappa is really useful. It measures the level of agreement between your LLM judge and your human evaluators, specifically correcting for agreement that might happen just by chance.
Okay, so you're using these metrics to really quantify its accuracy and, crucially, how well its judgments align with considered human judgment.
Precisely. The fourth step is simply to collect your judgments. You run all your test outputs through your LLM judge system systematically, making sure to maintain detailed records of the inputs, outputs, and the judge's scores and reasoning. And the fifth and final step is to measure performance. You analyze the collected judgments against your chosen metrics, precision, recall, kappa, etc., and compare them to your ground truth, either objective answers or human labels. This gives you a clear quantitative picture of how reliable and effective your LLM judge actually is.
And what's really helpful, I think, is that the source material, the ebook, even provides a conceptual framework for the code required to build such a judge. It shows you, kind of step by step, how you might set up the core judge logic, prepare data functions, implement the validation logic using those metrics, and then test it all together to measure its correlation with human judgment. That's incredibly practical for anyone wanting to implement this. Okay, so let's say you've done all that. You've built your judge, you validated it. Now, how do we push it further? How do we make it truly robust, reliable, maybe even fairer? Our source offers 7 practical enhancements to really level up your system.
Yeah, these are like the pro tips. These improvements can really turn a basic LLM judge into an exceptionally fair and thoughtful evaluator. First, and we've touched on this a lot, you need to actively mitigate evaluation biases. We talked about nepotism, verbosity, positional bias, etc. How do you fight them? Well, You can use multiple different LLMs as judges and average their scores to try and balance out individual model quirks. You can perform cross-model evaluation, where, say, GPT-4 evaluates Claude's output and vice versa, specifically to combat nepotism. For verbosity and positional bias, you might try techniques like extracting only the relevant notes or key points before evaluation, or systematically varying the sequence in which responses are presented to the judge. For consistency, running multiple evaluation passes on the same item and aggregating the results can help smooth out randomness.
So it's really about adding layers of checks and balances, maybe diversifying the judges themselves.
Exactly. Second big tip, enforce reasoning. We mentioned chain of thought earlier. Think of it like teaching someone to grade essays, not just by giving a score, but by requiring them to explain their thinking step by step, by making LLMs show their work, breaking down their evaluation into steps, explaining the reasoning behind each subscore, maybe even adding a self-reflection step. You generally get better, more consistent results. And critically, you understand why a judgment was made, which is invaluable for transparency and debugging.
Right, getting that why is key.
Third, break down complex criteria into components. Instead of asking for one overall quality score, which could be vague, separate the assessment into distinct, well-defined components like clarity, accuracy, relevance, safety, tone, etc. Score each component independently, maybe on a simple 1 to 5 scale. Then you can weigh these components based on your business priorities and calculate a final weighted average score. This helps pinpoint the exact strengths and weaknesses of the output being judged and provides much more actionable feedback for improving the underlying AI model.
Yeah, that's like getting a detailed report card with specific grades instead of just a single pass-fail mark. Much more useful.
Precisely. Fourth, always align evaluations with user objectives and context. You need to tune your evaluation standards to match your specific application's needs. For technical documentation, maybe factual accuracy and completeness are absolutely top priority. But for customer service interaction, perhaps empathy and problem resolution effectiveness are more critical. The evaluation standards shouldn't be one size fits all. They must adapt to the context.
Makes sense. Tailor the test to the task.
Fifth, utilize few-shot learning effectively. This means showing your LLM judge concrete examples of what good and bad look like for your specific criteria. Include examples of excellent responses, good ones, maybe mediocre ones, and definitely weak ones. Critically, these examples should showcase different strengths and weaknesses, and you should consistently demonstrate the reasoning behind the evaluation score given to each example. These examples act like anchors, setting a clear standard and guiding the judge's calibration.
So you're giving it a curated set of case studies to learn the nuances from.
Exactly right. Sixth, don't be afraid to incorporate adversarial testing. You need to proactively stress test your LLM judge. Feed it challenging responses, maybe ones that deliberately mix excellent points with subtle errors, or use unusual formatting, or include plausible-sounding misinformation, or even answers that challenge common assumptions in unexpected ways. This helps you spot where your evaluation system might stumble or get confused. It ensures it can handle the complexities and sometimes messy nature of real-world AI outputs, like technically correct but poorly explained answers, or beautifully written responses with subtle factual inaccuracies.
Okay, so actively try to break it to make it stronger.
In a controlled way, yes. And finally, seventh, implement iterative refinement. Your evaluation system shouldn't be static. It needs to continuously learn and get better. You need a process for tracking its performance over time. Look for scoring inconsistencies. For example, similar responses getting very different scores. Identify criteria that the judge seems to be missing or misinterpreting. Note down the types of responses that consistently challenge the judge and watch out for conflicting criteria. Then, based on this feedback loop, you make improvements, maybe refining your prompt structure, sharpening the definitions of your evaluation criteria, adjusting the weights, updating your few-shot examples to address newly found edge cases, or even swapping out the judge model if necessary. It's a continuous improvement cycle.
You know, what's really compelling here is how these strategies tackle some of the deepest seated issues, the biases that even human evaluators struggle with. These 7 strategies feel like a really comprehensive toolbox. Some fix common known problems like positional bias, while others, like iterative refinement and adversarial testing, help the LLM judge itself learn and continuously improve its own judgment capabilities over time. So wrapping up, we've taken a really deep dive today into the world of LLM as a judge evaluation. It's clearly a rapidly growing field and honestly an essential one for anyone seriously working with or deploying AI systems.
Absolutely. We've looked at why those traditional evaluation methods often fall short, especially for nuanced language tasks. We explored how LLM as a judge can overcome many of these limitations, but also discussed the critical importance of understanding and addressing its potential biases. We saw how specialized evaluation models, like the SLMs we discussed, particularly frameworks like Luna, are really transforming assessment with pretty breakthrough improvements in speed, cost, and accuracy. And hopefully we've provided a practical framework for how you can think about building and improving your own robust evaluation systems.
It really feels like the ability to effectively evaluate these incredibly powerful models is going to be a key differentiator for organizations in the coming years. It's not just about building the smartest AI anymore, it's maybe more about building the most reliable and trustworthy AI.
I couldn't agree more. And our source material really highlights that these frameworks and techniques we've discussed today, they aren't just theoretical concepts. They are, and I quote, battle-tested approaches that have genuinely helped leading organizations build more reliable, more transparent, and ultimately more effective AI systems in the real world.
So for you, the learner, listening to this, the ebook really stresses that the time to implement robust evaluation systems is now. What are your next steps? Well, maybe assessing your current evaluation approach, if you have one. Perhaps starting small, piloting LLM as a judge for just one specific use case to learn the ropes. Definitely focusing on continuously iterating and refining your system based on feedback. And crucially, building evaluation into your development lifecycle from the start, making it central to how you develop and deploy AI systems, not just some kind of afterthought tacked on at the end.
And this, for me, raises a final, maybe more philosophical question. In a world that's going to be increasingly shaped by AI, we're getting incredibly good at building these powerful models. But maybe the ultimate challenge, and perhaps also the greatest opportunity, lies in our ability to truly understand, validate, and continually refine them. How do we ensure that the intelligence we create is not just smart, but also, wise and trustworthy, especially when the judge we rely on to assess it is itself also an AI? It's a fascinating question to ponder as this field continues to evolve.